We're going to continue with MechFest. But before we start, I forgot something.
Oh, you forgot your coffee.
Oh, yeah, I forgot my coffee. That's okay. I got my coffee here today. Yeah. Here we go. Let's see what we got. Got this from my son and his wife. You see it?
I don't know that. Let me see it. I really like it.
Yeah. Trying to get closer. I don't know. Can you see the coffee pouring out?
No picture, no story on Instagram.
But no, I don't want to story on Instagram. It's going to be on our videos. This is for you and me. Okay. Okay. So we're going to take imines, and what kind of reaction is this? We're making it into an amine by adding what two new atoms? Two hydrogens across a pi bond. Oh, we did that in chapter 6. Hydrogenation is one of the answers. H2, comma, PT. Works for both. H2, PT. And you don't need pressure this time. Remember when it was a carbonyl, you would have to add pressure. That is a fact. This is not as polar a pi bond, especially the one on the right. Now this one, it's polar, but not very. And the reason why hydrogen and carbonyls need pressure is because hydrogen is a totally non-polar molecule. It doesn't like associating with polar carbonyls. It avoids them. It doesn't want to be near them. It finds them repulsive. And it's not a personal thing, it's just fact. Okay? So if you want a carbonyl to do the H2PT reaction, you have to force them to be together. So you're literally squishing them on top of each other with pressure. Here, you're not worrying about a polarity issue. They're attracted to each other to start with, they react. Okay? Now, the other answer is actually on the page. Can you tell me the other way to reduce the carbon, in this case, the imine, NaBH4. Yes, I condensed the thing below. Step 1 is NaBH4. Yes, that is the same as this, right down here. And step 2 is HCl. And what the heck? The mechanism is this way. Anytime you see this drawn like this, you will do that first. You will make H minus plus BH3, which you don't need anymore. H minus is attracted to the more positive carbon, and you're generating N minus. First step is over. NaBH4 step is over. And you got your new H. If you want to show it, here it is. I put it in green, be consistent. And what do you think's happening in the next step? It's pretty rock solid, ripping and roaring acid-base reaction. I would be careful too. You got a really strong base and a really strong acid. I would do this slowly, drop-wise, monitor pH as you go, but it's not a lab class. We don't care about these things. Okay, good. And we can put the NaBH4 HCl combination here. And as promised, it was a short activity because that's all. Oh, we're not quite done. You got to make this real. Got to make this real, don't you? All right. So you got two types of employees in your chemistry factory. You got the workers. And you got the boss, right? So the boss knows about doing stuff like this. In this case, the boss was a little more involved than most bosses. He actually hijacked a shipment of the methylamine that's drawn there on the arrow. I think it's frozen. No, it's not. So we got this. That's what functional group you got there? Imine, yeah, close, imine. That was just a pronunciation issue. And you're gonna react that with, well, you could use one of the two chemicals listed above. He didn't do it. He found a different catalyst. I'm trying to make this, I say make it real. I'm trying to make it fictitious because it's a TV show I'm talking about. Some of you might know. And he reacted instead of H2 and PT, he used H2 and some other catalyst, H2 and a copper catalyst. And as the story goes, some trace amounts of the catalyst, it doesn't take much, like 0.001%, were in the product when he was done, and it rendered the product blue. Anybody know what show I'm talking about? Somebody said Breaking Bad. Yes. This is Walter White's synthesis right here. Yeah. The process is cleverly called, this being a reduction at the end. Reduction. Yeah, reduction. What color would a reduction be? There. And this is imine formation, the first one. Imine formation. And overall, this is one of the most common ways to make amine because it has very reproducible chemistry. It's very general and it works almost every time. And the name is excellent. I love the name. Reductive. And it looks like a typo. Look at that second word. It does look like a typo, doesn't it? Looks like you're making cartoons. No, you're not. You are making an amine. Okay, and that there is methamphetamine right there. A very big problem in this country. You know that, right? Not quite as big a problem as Ms. Bustani talked about during her presentation, but it's still a big problem. And there you go. You don't need any of the Walter White stuff there. We are done for the day and for the week.